This video is an addendum to my last devlog for my first-person platformer about rocket jumping. I won't be re-explaining everything I spoke about in that video, so if you haven't, you should at least watch that one for context. I didn't expect to be making another devlog solely about game mechanics so soon, but I've taken some feedback from the comments on my last video and made some very impactful changes. In talking about these changes, I'll be going deeper into the inner workings of my engine, so hopefully that will be interesting. So let's get into that. I've received many comments with suggestions for the game, though there are two specific comments that have inspired me to make the changes I've made. This is the first one, and while I had to disqualify two suggestions right off the bat, and save the suggestion about rocket trails for when I get to implementing more visuals, the subject of the other two, fire rate and sliding, are what I'll be discussing today. As I explained in the previous devlog, I chose values for the player and the rockets to allow for accessible pogos, and when I eventually found a set of values that fit that goal, I just stopped working on it with little regard for the other gameplay implications. This comment helped to bring those implications to my attention, and in service of that, I made some tweaks to the general game physics to hopefully allow for more interesting level design. While this comment was correct that the fire rate was too fast, I actually found that in conjunction with the rocket strength values, this made the rocket launcher more underpowered than overpowered in some situations. This is because for pogos to function while firing on the first possible frame every time, I had to make the rockets less powerful compared to TF2, which has a downstream effect for jumps like sinks, where they become much less powerful. Because of this, I decided that making rockets apply more knockback, combined with a lower fire rate, would be beneficial. And with that baseline, I can make pogos work by changing other values like explosion size and gravity strength. This comment also mentioned the prospects of jumps off walls being too overpowered, and this is unfortunately something I have little control over. I believe the difference comes with how I determine rocket strength, which allows for a 100% full strength jump to be executed off of a wall, just the same as a jump off the ground, whereas in TF2, jumps like this off walls are weaker in general. But when it comes to my design principles for this project, this is an acceptable compromise. My philosophy is that with more leniency in timing and angles, comes more players who will be able to enjoy the game from a new player perspective, and potentially become interested in finding and executing on those fastest, optimal strategies. When it comes to making the game more accessible while not compromising on the depth of high-level play, this aspect is not perfect, but it's acceptable. I'm going to see what I can do to get them closer to TF2 than they are now, but if I can't, I'm fine moving forward with this current implementation. One last physics change that's separated from rocket jumping is that I made air strafing slightly more powerful by increasing the air strafing speed cap. I won't go over the intricacies of this here, since I already did in the first devlog, but the bottom line is that this allows you to take tighter turns while air strafing without losing speed, as well as allowing more speed to be gained while surfing. I found that the initial value for the airspeed cap I had was fairly in line with TF2, but I did figure that with the amount of speed you can build up and maintain in my design, making air strafing more powerful is warranted. The value I settled on should be somewhere in between TF2's default air acceleration and standard surf settings where air strafing is made incredibly strong, which I find to be a good middle ground. Now here's the second comment I pulled from for these changes, which was very helpful for understanding rocket jumping at a deeper level than I did previously. While this comment doesn't directly give any suggestions or advice, the fourth bullet point in the first comment, as well as the information about how sliding on slopes works in TF2 given in the second comment, pushed me to overhaul how sliding on slopes functions in my design. I'll admit that the implementation I laid out in the first devlog was somewhat hacky and not fully thought out in a few different ways. Firstly, I implied that rocket jumping off slopes with my previous implementation wasn't finicky, while it absolutely still was. But more importantly, if you let yourself slide off the slope without pressing anything, you wouldn't maintain any of the slope's upward velocity like you would intuitively expect. Along with this, the way that I increased jump height while going up slopes was an interesting idea, but felt counterintuitive and was probably too overpowered at higher speeds, where you could get more Y velocity by just jumping than a perfect rocket jump on flat ground provides. With this in mind, I completely removed jump height scaling on slopes, and allowed rocket jumping while sliding on slopes, regardless of how recently you had initiated your slide. The third change I made was definitely the most complicated one, that was part of my apprehension to design sliding on slopes this way, which requires that I talk about the engine I'm making this game in. I've mentioned it a few times, both in my Discord server and under comments, but I'm building this game in Godot at the moment, and for my player controller, I'm using a built-in node called Character Body 3D. This node type comes with very helpful parameters and functions for player-controlled characters, and for nearly everything it's worked perfectly, with a few easily fixable snags here and there. But because of how slopes are handled with the built-in move and slide function, I've had to implement a somewhat hacky solution to allow for flying off slopes as seen in TF2. By default, when you walk up the ledge of a slope like this, the collision system will actually register the very top of the slope as a flat surface. So if you run off the slope like this, you won't maintain the Y velocity from the slope because the game will register you as walking on a flat surface before falling off and remove that Y velocity. Along with this, Y velocity when walking up and down slopes is stored in a separate velocity vector that the built-in movement function uses. This is good for most situations, since you don't want the velocity vector that you change with your own code to change unexpectedly when on slopes or moving platforms, when you can just let the built-in function handle it for you. But I had to bypass these two normally helpful features in the very specific situation where you slide off of a slope at a high speed while moving up. I first checked to see if the slope angle before moving is greater than the slope angle after moving, which will catch if the angle of the slope changes to be less steep in any way after moving, as is the case with the edge of a slope like this being flat ground. Then I checked the slope Y velocity before and after moving to see if it's changed in the same way, which together with the slope angle check confirms 100% that the player has moved to a shallower slope on that frame. Finally, I don't want the player to leave the ground when leaving a slope at normal running speed, so I checked to see if their velocity is above the max running speed, which ensures that this will probably only happen during a slide and only at high enough speed. If all these checks pass, the fake Y velocity will be applied to the real Y velocity, which will smoothly transition the player into the air, moving in the exact same direction they were on the slope. This implementation maintains all the positive consistency improvements that my initial attempt had over TF2, while increasing its consistency further and making it more intuitive to get the most distance out of slopes like this. Whereas previously you would have to buffer firing a rocket before jumping in order to fire on the first possible frame out of a slide, you now simply have to slide along the slope and fire a rocket at your feet before the end of the slope in order to get the best jump, which is much less finicky and awkward. I'm going to be testing more changes to slopes in the future, like gaining speed while sliding down slopes, but when it comes to sliding and ramping off slopes, this is an implementation I'm very happy with. So thanks to these two commenters and everyone else who left their thoughts for giving their feedback and helping to improve the game. I'm still working on the next devlog with a more concrete visual style and some tutorial design, so subscribe to the channel if you want to keep up with development. That's all I have to show for today, but hopefully I'll have more to show you soon.